Let's take a look how we can create a simple render in Blender with lights and cameras and all the rest of it. I'm going to show you this process twice, once just with the character so that we get the basics down, and then once with the character in a sort of environment scene so I can show you a little bit more about depth of field and how that works. So if you compare creating a render to DAZ Studio, there we just go Control R, whatever you see in the viewport gets rendered out, the end, you can save it, that's that. But in Blender things are a little bit more complicated. So the ingredients to create a render are that we can't really render what is in the viewport. I mean, we can change this over to the rendered preview, but that doesn't mean it gets rendered out exactly that way. For that, we need to have a camera object through which we need to look and position it so that whatever we look through the camera, whatever the camera sees, gets rendered out as a picture. We also need lights, because without lights we get a completely black scene. And we also need to pick a render engine in Blender, either Cycles or Eevee, or more specifically as of, I think, Blender 4.2, it is Cycles X and Eevee Next. So those are sort of improvements over the older versions of Cycles and Eevee. They've had some performance improvements, but also quality has been improved. So we need to provide that. And last not least, we can go and create multiple renders and compare them directly inside Blender. This happens without the compositor. So let me just show you this super easy 645 step process with my colleague Rain here. Rain, whom we've met in the previous episode, I have posed her just in a standing smiling pose. And the first thing I'm going to do is hide all the pose controls. I'm going to come out of pose mode, go into object mode, and I'm going to go and switch off the bones so that we can see the character here. And it's not a great pose, but you know, I've posed her, so there we go. So in order to create a camera, there's sometimes if you already have a default camera in there, you can use that to move it around. I don't, so I only have the character. Let me go and create one with Shift A, and then I'll go down here under camera. So that will make a camera object literally in the center of the scene or wherever the 3D cursor is. There's two ways that you can move the camera. First of all, to look through this, you can press 0 on the numpad, and that will go and look through that camera. If you press 0 on the numpad again, it goes and toggles back to your viewport. If you do this and then move it around, then you will see that you switch back to your sort of director's camera, if you will, and then you have to press 0 on the numpad again to go and look through that camera again. Now there is also a way to adjust what you see here. So as you make movements, they will be incorporated into the camera. You can of course also move the camera around. So GY would move the camera in or out, GZ would move it up and down, but that's not a very intuitive way of positioning the camera, but you can do it if you had to do that. One other thing just before I start telling you about all the nitty-gritty, if you had multiple cameras, so I can just go and Shift A and create another camera object, only one of them at a time can be the so-called active camera, and that's the one that we use to render through. So let me go and bring up the N panel here and go over to View. And there is an option here that says camera to view. If I select that and then press 0 on the numpad, I will still look through my camera object, but you can just about see that little red dotted line on the outside here. That goes away when I untick camera to view. See that? So yellow means this is just a kind of the camera part 2, if you will, which we can enable and disable. Enabled means we see whatever is not being rendered sort of grayed out here. But then beyond this yellow line, you see that red dotted line. If I enable that camera to view, then I can move my viewport and the camera will sort of follow. So now I'm really positioning the camera as I move my viewport controls. And that is a way for me to make an adjustment there. There's another way to do that, because you might already have the viewport dialed into something that you want to turn into something like a camera preview. So let me go and get out of this by unticking this box, camera to view, and then just go and toggle around. Here's my camera, this is that camera object. Imagine I had something framed up that is sort of like this. And I'm thinking, yeah, this is how I'd like to shoot my picture. This is what I want to render out. There is a way to move the camera into the position of approximately what the viewport shows. And you do that with Control-Alt-0 on the numpad. And that will sort of snap my camera to where my viewport was. I mean, almost, not entirely, because there's a couple of other things that we need to take into consideration, namely the camera's focal length and also my viewport's sort of preview focal length, if that makes sense. When I do that, I can go and click that little option again here, camera to view, and then I can make adjustments, like fine tune, if you will. But that means my camera sort of gives me a bit of a head start of what I've seen in the viewport. That's sort of what ends up on my camera. So yeah, red dotted line, make sure you obey that at all times. Let's talk about aspect ratio here just for 1 second. By default, that is set to 1920 by 1080, as we can see that here. If I go and untick this, I can go and zoom the viewport in a little bit, make that a little bit larger here, but the aspect ratio isn't gonna change. So if I wanted to have a square render or portrait render or any sort of other resolution, that is something that I need to actually set in the output settings. That's here on the right hand side. This at the top here, those are my render settings. This is where I set my render engine here, Cycles or Eevee, or also Workbench, but Cycles and Eevee are the ones that we deal with. Eevee is sort of the real-time render engine, or the faster one. That is the biased render engine, so it uses some shortcuts to create an image much faster. But Cycles provides full path tracing, which takes a bit longer. It's a little bit like iRay in DAZ Studio, but it also provides the more accurate results, but it takes more compute power. In the case of Eevee, I can also say, do I want to render with the CPU or the GPU? And the GPU, just to bring that to a close, as I said, 465,000 million steps here under Edit Preferences. And system, you can set what GPUs you want to use for rendering. So you can use either the GPU or the GPU and the CPU, and also what type. Do you want to use CUDA, which is only available in NVIDIA graphics cards, Optics, which is also only available in NVIDIA graphics cards, One API, and HIP. I think those are available for Intel and AMD graphics cards, which I have zero experience with. So, you know, Optics or CUDA will do a fine job here, and untick the CPU if you're rendering with the GPU. If you do want to render with the CPU, just switch that over to CPU. That's that. Aspect ratio, that's not on this one, on the render settings tab, that is on the output tab. If you click on that, at the top here you see the resolution and you see the aspect ratio. So you can either leave this as it is, 1920 by 1080, and then bring down the percentage, which will make your render smaller, or you can go and change it to something completely different. Like if I go and say 2000 by 2000, then you'll see that my Passepartout here changes to a square, and you can now go and frame this up any which way you want. Or you do something like a portrait, like 2000 by 3000, and then I have a portrait, and now you can go with the end panel again, camera to view, and then you can go and frame up the shot as it needs to be. So that is how you set the aspect ratio. Let's talk about focal length just a little bit, because that is something that you need to set on the camera object, of course, and that is something in which you have to first of all select the camera. I've got mine selected here already. If you haven't, then make sure it is either from the viewport here or from the scene outliner. Either way will work fine as long as the camera is selected. And once again, 0 on the numpad will frame that object up. Then you can go down here to the camera icon. This is called the data properties here. That is where all the camera properties are. So the default is a 50mm length, and you can go and change that to something bigger or smaller. Smaller values mean you frame more of your environment. So like 10mm would be something that is very wide and it distorts the perspective quite a bit, as you can see here on my character. Or something much more flattering for portraits is something higher than that. So something like 150, 200. And then of course you have to dolly the camera back, and then you'll see that the perspective gets flattened out, and that is more flattering for characters and for portraits generally, because otherwise you have these distorted features as you get very close with the camera to your object. If you want to be further away, it flattens out the perspective, and that looks a little bit better. So let's say this is something we want to frame up, and let's say we're good on the 150 millimeter focal length here. Now all that remains to be done is render out the image. So that happens, you can do that in two different ways. You can either go and press F12 on your keyboard, and I'll just go do that while I talk what's happening here in the background. A new window opens. You can go and scroll your mouse wheel in and out so that you can see the full picture if it doesn't fit on your screen. And first it renders it, and then it started denoising it, and then we have the image here. So it doesn't look very good because we haven't set any light. So whatever light we had in our scene must be sort of ambient light, and we'll come to that in a moment. So there's a couple of things that I wanted to bring to your attention. If you wanted to save this out now, you head over to Image, and then you head over to Save As, and then you can go and save it anywhere you like, in any format you like. So PNG will preserve transparency if you switch to RGBA. You can also use RGB, in which case transparency is not preserved. You can also pick a color depth here on PNG, or you can pick an entirely different format: bitmap, JPEG, JPEG 2000, any of these things. So even WebP, so Blender supports all that. And down here you can set it, you can give it a file name. But sometimes what happens is that you make several renders and you want to maybe compare them, like, you know, render settings and render time and this light here, this light there. You don't have to save this and close this window down and then make a re-render. You can just render another image, another pass, so to say, to a different slot. That's kind of a nice way that Blender offers us here under the slot option. So I've currently rendered to slot 1. If I switch over to slot 2, that is currently empty. That doesn't show me anything. But I'm going to leave it on slot 2. You can close it down, you can minimize it. I'm going to go and minimize it, and let's talk about lighting. And when I go and press render again, it won't render, it won't overwrite my slot 1 image. That'll still be there. It'll go and render to slot 2, and then that lets me go and make a little comparison between these two. So I find that quite useful. It's quite exciting. Let's do lighting, because our first pass didn't come out so well. So lighting is one of those things that's really the make or break of a render. And I'm going to go and Shift A to bring in a plane mesh here, just so that I have a little bit of a floor. It's not going to be something spectacular, but it'll let us have a look at shadows in a moment. So while you set lights, it might be a good idea to preview what they actually do, and that's where you go and switch over to the third option here in your viewport, which is the viewport shading. So it'll go, if you select that, it'll go and render the whole viewport in the render engine of your choice. So in my case, that is Cycles, and we're going to speak about render settings in a moment. Let me go and illuminate that character so that it looks good. Usually you would go and use something like 2 or 3 lights for that. You can use a single light, Shift A, and we'll go and use a light object here. I'll use a point light that comes in at the center of the origin. So I'm going to go and move that up with GZ sort of to over here, and G Shift Z moves that over to sort of here. And let's call that one, let's say, the fill light. G Shift Z a little bit further away from here. So it's not as strong as I wanted it to be. And also go and look at the shadows. They're very harsh right now. I can see very defined shadows here. Without that mesh, without that plane mesh, you wouldn't see the shadows. So plane is good to just, you know, catch the shadows there. So to make the light a little bit brighter, let me take my face out of the way. That is once again on the data property here with your point light selected. I might go and rename that. F2 will do that. So let's go and call that the key light, because that's sort of the main light source. Make it a bit stronger. Let's make it 20 watts, or maybe even make it 50 watts. That might be a bit bright, but let's get rid of the harshness of the shadows here. And we're going to do that with a radius here. 0 means it's literally a point light. So that means it has the size of a single pixel. And that means it's so small, it gives us a very harsh shadow, and that doesn't look great. If you look at the face here, whoops, if you look at the face here, it looks very harsh here. We don't really want to see that. So by making that larger, key light, say to 1 meter, you'll see immediately what happens. The shadows are now so soft that I can barely see anything. So 1 meter is too big for me, so maybe I'll make it 0.5, so that's half a meter, and you'll see a bit of shadow coming in here. 0.2, that might make it just like what the doctor ordered. So now we have the softness of the shadow, but we still have shadow definition here. So that's my key light. In order to fill out the other side, and at any point you can press 0 on the numpad to see what your actual camera framing is going to look like. The opposite of the key light is the fill light, and the fill light is there to flesh in some of the darker areas. Fill light doesn't have to be as strong as the key light, but the key light is certainly the one that provides sort of the main direction of the light. And in portraits, it either comes from the left or the right. So mine comes from the left here. Shift D, I'm going to go and move my fill light over to the other side. And now we'll see that the fill light provides the same strength as the previous one. I might go and put that over here, and that is a bit too strong. So I'm going to go and turn that down to maybe 10 watts or maybe 20 watts. Depends. I think maybe 15, something in the middle. So with this off, we have that shadow here. With it on, we fill that in, and you can fill that in as much or as little as you want. Make sure it is filled in a little bit rather than flood fill the whole image, because that's just not going to look very nice. I'm going to go and rename that here and call it fill light. So usually this is already an okay portrait, but it still looks very flat, and we have a little bit of definition here, but we don't have something that describes the character in 3 dimensions. And that's usually where the rim light comes in, or the kicker light or something. That is a light that is usually sort of opposite the camera, so it'll be behind the character, and its function really is to shine a very harsh light from the back of the character, and then we'll see a lot of definition on the other side. I'm going to go and just duplicate this one, Shift D, Shift Z, and just move that to the back, sort of opposite the camera is a sort of a good rough direction to have. It's currently not strong enough, and it's also very soft. So let's make it 0.1 in the radius, and maybe the power might make that 500 and see what happens. We don't want it to be too strong. So point lights, remember, they're cheap and easy, but that also means they shine in all directions. So if you wanted a little bit more control, you can use spotlights for this, or you can use something like rectangle lights for that. But I'll leave that for another exercise. So I can see the subsurface scattering on the hands is now, it's too much. So we probably don't need it to be quite that much. I want to make it a little bit higher here, and I can see the effect that I was after, which is this sort of shining light here. I might go and make it a little bit larger, 0.5, and then you see that this area is increasing here, maybe even 1 meter. Let's see what that looks like. That's sort of getting there. 500 is a bit too much. I don't want to see these white areas here quite so much, so maybe I want to make it 300, but I'm also going to make it G, Shift Z, move it over here, and just, you know, I'll go and move the light around, and you'll see what works best. And this is something that you just have to go and practice with. Do you need to move it closer to the character? Do you want to move it further away? See what the effect is on your render. And this is the basics of a 3-point lighting setup. Blender also has this option that you can move lights in one viewport around while keeping an eye on it in another. So this is something that I like doing by just making another viewport here, left click and drag that open. And let's say we want to go and keep the camera in this viewport. So hover over this, press 0 on the numpad to look at it through the camera here. In order to move this to a rendered view, you can either make this bigger and then click this button here, then this viewport will be rendered. Or if you don't want to do that, you can also, once these icons here are occluded, use the middle mouse button and scroll the whole thing over here, and then you can switch this to the rendered view. Let's keep an eye on this. While in this viewport, I can go and maybe better position my rim light here, which I should rename. There it is, rim light. So G, and then you can go and move it around, and you can see what the effect is on your render. Now, I'm currently doing this all in cycles, but if you were to switch this over from cycles to Eevee, you'll notice that the render engine changes here, so it needs a moment to recalculate the image. But once it's done that, you'll see that the image still has a very good character. And back in older versions of Blender, you had to go and click a couple of extra options like screen space reflections. Thankfully, you don't have to do that anymore. And ambient occlusion, that was the other one. Thankfully, you don't have to do that anymore to get a good looking lighting out of this. Compiling shaders, that just happens on the first time you run this in Eevee. Oh, your working viewport doesn't actually need to be in the rendered view. You can just be in the regular viewport shading, and that'll save you some rendering resources. So this is more like a preview of where objects are, and this is your preview of what your render is going to look like. So she almost looks okay in Eevee. I mean, if I look at the body, that all looks fine. We even see a little bit of the subsurface scattering on the fingers, but the eyes, obviously I can't really live with that. So I'm going to go and switch this back over to cycles, and then we're going to stick with cycles for now. One last thing before I click render, we need to talk about render settings. How many samples am I going to render with? Am I going to render with denoised viewport? And how strong do all these things need to be? So those are all things that you can set on the render settings tab here. Let me go through the pertinent ones. So the two that are most important are the ones for sampling here. Sampling is the one that tells you how long the image is going to cook. And in the viewport, we have settings here, and then we have the settings for the render. So denoise is obviously the denoiser, which is on by default in both the viewport and for the final render. But the samples for the final render are slightly higher than the ones for the viewport. So 32 is what we currently see here. That is not a lot, I have to say. And if you zoom in closely, you can sort of see that there's room for improvement in this render. So if you wanted to set this to something higher for testing, you can do that. So if I go turn this to 128, then Blender goes and renders that. It looks a little bit better, but you might not be able to tell when does my image actually look okay, when does it look its best. So you can go and set this number to 0 and then keep an eye, press enter, keep an eye on what Blender is doing up here. So these are the samples it is casting. These are all the ray bounces basically. And you can wait until you have a value that you're absolutely happy with. So, 5,000, that might be overkill. Notice that when you make a change, it starts again from scratch. But usually a lower value is there so that you see a result quickly, and also that the render then stops. So as you move your viewport, you reposition things rather often. And like if I do this, every time I start moving my camera, it starts counting the samples back, but it never stops rendering. It always renders in the background here. So if you are happy with the 32, then that's fine. Or if you want to set it to the same that you will see on your final render, like 128, in my case, it's extremely fast, but that's because I don't have a lot of objects in my scene. So once you've made that decision of how many samples you want to render with, and please do test this out. You can go and type in that number on your actual render samples option here. Let's say 512. And this is now going to render 512 samples of whatever's going through the camera at the resolution that we've set on the output tab over here. So 2000 by 3000, and it'll happen with 512 samples. Now, the other thing that we should discuss is the denoiser. And the denoiser is a little bit more complicated than it is in iRay. In iRay, we have literally one box that says, do you want it or do you not want it? I recommend you always have it on. Don't blame the denoiser for the fact that the picture doesn't look good. The denoiser always does a better result if you let the picture render for longer. So if we open this up in viewport and render settings, it's basically the same, but I'm going to use viewport here so that you can have a little look what's happening here. So first of all, you have the type of denoiser. Automatic means it'll just work it out. It'll work out whatever works best. But if you drop this down, you have two options. So you have optics in my case, and you have open image denoise. So the difference is that in my case, I have an NVIDIA card, an RTX 3090, and optics is a denoiser that's built into the hardware and that can be utilized, and Blender detects that. If it wasn't there, it wouldn't come up as an option. So that is something that I can use. I can let the GPU render and then also take care of the denoising pass. But if I have a strong CPU and a strong GPU, then I could also free up some GPU resources and let the CPU do the rendering using this thing here, which is called the open image denoise. That's an Intel technology, and that means my GPU in my case will be used for rendering, but the CPU will be used for denoising. So that's sort of cool if you want to give the GPU a rest, or if you want to let it cool down, especially if you're rendering long animation sequences. That's sort of a cool idea to do, but it'll depend if you have a fast CPU or a slow CPU. Open image denoise is an option. So You can pick the one that works best for you. You can also see what passes you want to use. So none means it only does one pass, albedo means it filters the color, and albedo and normal filters the normal details as well as the albedo or the base color pass. And then quality, you can use whatever you want, something faster, something balanced, or something higher quality, and you can tell after which sample this is supposed to start. So I'm going to go and leave these in the viewport as they are. And in my render tab, I'm going to use open image denoise like it has already come up with here. And I'm going to go and use F12 to render this, and we'll see what this looks like. So as I said before, this is now going to come out as in slot 2, and we can directly compare it with slot 1 in a moment. So you could compare denoiser passes and just see which one you like. The fact that I get these two sort of half squares here is that the GPU tries to render in tiles. So it's an interesting one. The tiles are like smaller squares, and the CPU generally renders faster if your tile size is very small, and your GPUs render faster when your tile size is relatively large. So like 512 or 1024, or depending on the VRAM size of your GPU, it'll be dependent on that. Under view up here, you can go and frame all, which is also the home key here. So if you have something like this and you want to see this as full as the screen can make it, press the home key. Or you can go and press something like percentage. So if you wanted to see this at 100%, 1 on the numpad will do the same thing. And then you can go and have a look at if this render looks the part. So I think it looks pretty cool, but we can go and compare this. Look at the normal details on here as well, but we can go and compare this with something that is less denoised, more denoised, or uses less samples. So what you usually might want to do is if I go switch this over to slot 3, and I want to know what happens if I just use, let's say, I don't know, for the sake of argument, 32 passes in the render, and I'll use the same denoising as before, hit F12, and then this is now going to go into slot 3, and we can have a look which one looks better. So obviously 32 samples is much faster than before. 1 on the numpad will go and show me this result in 100%. So now I can go and compare this and that, and then you can make an educated guess. Hey, were 32 samples maybe enough, or did I need that? Well, I can actually see that with only 32 samples, I see less detail over here in the eyes than I do see with my 512 that I had before. So there's more detail in here. Let's go have a bit of fun and go into slot 4 and render once again, perhaps with 128 passes, but without the denoiser. Press F12 again, compare render results. So first of all, you'll notice that once the render is done, I'll see my image immediately. Before that, there was a little gap and a little pause. That was the denoiser pass. So denoising takes a little bit of time, no matter if you do it on the GPU or the CPU. But there we go. This is now my result without the denoiser. And you'll see that the denoiser did a pretty cool job. So if I wanted to have the same result as I had with the denoiser, but I wanted it without noise, perhaps I'm going to go into slot 5, and then I'll go and try my luck at, say, 4096, hit F12, and this is going to probably take a little bit of time. As it does this, it gives you a bit of an estimation of how long this is going to take until it's done. It also tells you other things like, how much memory this render is consuming, how many tiles it's using, at which render sample it is, and so forth. So this is kind of funky information that you can play with and keep an eye on. If you render an animation, it'll tell you which frame of the animation it is rendering, and this is what we usually use this for, rendering animations in frame. So you can imagine how long that takes, and also you can imagine why we want to keep that on the smallest amount of samples as possible, because that really has an effect on render time overall. There we have it. It took about 2 minutes and 12 seconds. And as you keep an eye on this, there's also, it says last, and that is what the previous render pass would have taken. So it doesn't say that anymore because it's finished now, but there we go. Now you can go and compare these things to your heart's content and see which render setting you need for your final draft. And then once you're done, you can go and hit image and save as. So to recap then, and I know these were a lot of steps, but in order to set up a render, you need to have a camera. You can't just render the viewport. You can preview the viewport, but you can't render through the viewport. You have to have a camera for that. The camera needs to have its settings such as focal length and also depth of field, which we're going to talk about in a moment here. Then you need to go and frame it up. You do that by selecting the camera, and then you need to frame your camera up, which you do that by 0 on the numpad. If you did have multiple cameras, you can also make one of them your active camera. That is done under view and then cameras, set active object as camera. So if you had multiple, then you can use that. If you did have a viewport set up that you wanted to frame up, it is Control-Alt-0 on the numpad to turn the viewport into what that current active camera is currently looking at. And then you have the render dimensions over on the output tab. This is where you set if it's portrait or if it's landscape. And then on the actual render tab, you have the render engine, and then also under sampling, how long you want the image to get cooked so that an adequate quality can be achieved, including the denoising. There are many other things here, especially at the bottom here under color management and film and all that. This is where if you enable transparency here, then you go and render that background transparent. That's under the film section. That's just one other thing. If you did want to do any post-production on this, that needs to be on, otherwise the transparency wouldn't get saved with the image. And then down here under color management, you can go and pick something like a filmic look here. I think the default is none, but if you switch this to something like high contrast, then you see what the effect on that is. So it's not quite post-production, but it will give you something that might look better than not applying anything here. So it's entirely up to you. This is usually set to none, and that's how that comes out, and you can do all the rest in post-production. Let's take a look next how we could render a character in an environment and talk about how we set up depth of field and go through all the whole process one more time.